I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. Let me thank all the subscribers and viewers for watching my videos and posting excellent comments. In this video, we are going to discuss a very important question based on conditional probability. I would like you to pause the video, read the question properly, answer, and then look into my suggestions. Here is an excellent question based on conditional probability. We'll try to answer this question with the help of sample space diagram. The question is, two standard six-sided dice are thrown and the sum of the numbers is recorded. One dice is red and the other is green. A. Draw a sample space diagram showing the possible outcomes. B. Given that at least one dice lands on a 5, find the probability that the sum on the two dice is more than 9. C. Given that the red dice lands on a 5, find the probability that the sum on the two dice is more than 9. You can now pause the video, answer the question, and then look into my suggestions. In case you want to learn from me, you can always contact me on the email address given here or write on my website, theglobalmathinstitute.com. Now, let us see how do we solve such a question. So we are talking about conditional probability, where the condition given to us is that two dice are thrown. If at least one of them lands on 5, then we have to find the probability of getting a sum which is more than 9. Part C is when the red dice lands on 5, then we have to find the probability of the sum on the two dice is more than 9. So first thing to understand is that these two conditions are actually different and you should be expecting different answers for these two. So while going through my solution, you need to understand why they are different and how do we work with it. Well, to begin with, we'll draw a sample space diagram showing the possible outcomes for the given situation. Let me also review with you what is, after all, conditional probability. As most of you know, when we talk about conditional probability, in that case, if the probability of an event can change depending on the outcome of the previous event, then the concept of conditional probability will be used to solve these situations. A vertical bar is used to replace the conditional probability. Normally, it is written as probability of B when A has occurred. So this should be written as probability that B occurs giving that A has already occurred. It is also important to note that if the two events are independent, in that case what happens? If the events are independent, then the probability will not change. That is to say, that probability of B when A has occurred will be same as probability of A when B has occurred, and the probability will be product of the probabilities of A and B. You get the idea. So that is when the two events are independent. Now, to solve this particular question, we'll actually follow a very important concept, and that is restricted sample space. So let us first understand this concept. Conditional probability situations can be solved by restricting the sample space of the outcomes to the event that has already occurred. We'll see how this principle will be used to solve our example. So now let's begin with the drawing of sample space diagram. So we are given two standard six-sided dice which are thrown and the sum of the numbers is recorded. One dice is red, the other one is green. So let's see, how do we draw the sample space diagram for this kind of a situation? So basically, any die, six-sided dice, can give you six numbers. And we could make a row and column which shows these numbers. So let us say the numbers are 1, 2, 3, 4, 5, and 6, which could occur on the first die, which we are treating as red. The other one, 1, 2, 3, 4, 5, and 6. So that is for the other dice. And when you add them up, what numbers do you get? Well, if you add 1 and 1, you get 2. And when you add 1 and 2, you get 3. So let me just complete this. 2, 3, 4, 5, 6, 7. Similarly, 2 plus 1 is 3. So we can quickly complete this table, right? Okay, 3 plus 1 is 4. So 4, 5, 6, 7, 8, 9. And here we get 4 plus 1 is 5. So 5, 6, 7, 8, 9, 10. 5 plus 1 is 6, 7, 8, 9, 10, 11. And then 7, 8, 9, 10, 11, and 12. So that is the sample space diagram for the given situation where two dice are thrown. Is that clear to you? So there are in all 36 outcomes, right? So we have 36 outcomes. 6 times 6, as shown in this particular diagram. So that completes the first part. Now, using this diagram, we can actually solve part B and C. Let us see how. So for convenience, I have again sketched here the same sample diagram, and we'll try to solve the question, which is answering part B and C. Part B is, given that at least one dice lands on 5, so it says at least one dice lands on 5, find the probability that the sum of the two dice is more than 9. So when we say at least, then either the green one is on 5, so let me just shade what these are possible numbers. Well, if green one lands on 5, then the sum could be 6, 7, 8, 9, 10, or 11. And if the red one, at least one means either one of them, right? So then the sum could be 6, 7, 8, 9, 10, 11, as shaded here. So in this particular condition, we see that the condition given to us is at least one lands on 5. So that means we have restricted the domain, right? So now we can work on the restricted domain. As shaded. So we are talking about at least one. So those, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So do not count 10 twice. So when we say that, in that case we have 11 are the total outcomes in the restricted domain for the condition given to us. So it says, given that at least one dice lands on 5, find the probability that the sum of the two dice is more than 9. Means it could be 10 or 11. So let us circle when is it more than 9, right? So it is more than 9 in three conditions. So the probability is 3 over 11. Is that clear to you? So that is how we will get the solution for part B. So for part B, we have 3 over 11 as the answer. Correct? Absolutely clear? Now, let's look into the second condition. So let me erase this now and let's look into part C. It says, given that the red dice land on 5, find the probability that the sum of the two dice is more than 9. Now, in this case, we have restricted ourselves to only red dice. Now the possible outcomes are restricted, and how many are there? We have 1, 2, 3, 4, 5, 6. So there are 6 possible outcomes. And out of these outcomes, how many are favorable outcomes? We want more than 5, right? So in this case, we have only red dice lands on 5, and that's why we shaded that. And now we want the sum to be more than 9. So the conditions which give us more than 9 is 10 and 11. So there are two ways which are favorable. So 2 out of 6. You see that. So favorable over total outcomes, or it could be written as 1 over 3. So that becomes the solution for part C. So I hope now this concept is absolutely clear. So as explained that there are some conditional probability questions which we can solve using the concept of restricted domain. So in the first condition, it was either of the two could have fallen, and so we had that possibility. Now, in the second one, we had the possibility of only red, as shown here, and therefore the restricted domain was different. And that gives us two different solutions, as you can see from here, right? So, that is how you could do it. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. Thanks for your time and all the best.